So today's video is on glide reflections and compositions. So a composition of transformations is simply two or more transformations are combined to produce a single transformation. So we have looked at, we have looked at compositions before. So in our reflections unit, we would have a reflection followed by a reflection. So we would take our image to get our pre-image to get our first image, and then our first image to get the final destination. We're also going to look at a very special composition known as the glide reflection. Glide refers to the first transformation being the translation, and reflection because our second transformation is a reflection. So the composition of two or more isometries is an isometry. Remember, isometry does preserve the length. So this means that our pre-image is congruent to the image, which is going to be congruent to our second image. And all of the transformations that we've worked with so far have been isometries. So we are going to continue to work with congruent figures. So just a little reminder that you will need your transition charts for reflections and rotations. So for a reflection, look at your line of reflection to get your way to change the coordinates. And for a rotation, you need the angle of rotation, the center of rotation, and the direction of rotation in order to figure out how to change the points. So here is our first set of example problems. We're going to try to match our diagram to the correct composition description. So remember, we have three different items. So we have translations, where we shift our object. We have rotations, where we turn our object. And we have reflections, where we flip the object over a line. So this is a matter of seeing which picture does what. Make sure we follow our objects in order. So when we look at this in problem 1, our pre-image is A. Our first image is the A prime. And if we look at how we got from one to the other, this is a matter of twisting or turning the object. So this is one of our rotations. And then if we look how to get from A prime to a double prime, which is our final destination, this has flipped over the line. And when we flip over the line, it is a reflection. So we're looking for the one that has a rotation followed by a reflection. So a rotation followed by a reflection means that problem 3 matches up with this particular diagram. So this is a rotation about Q, then reflected in line L. In the next one, we locate A and A prime. So this is not just a simple translate. We didn't just shift it over. It's oriented differently. We didn't flip it over the line, so we don't have the mirror image the exact same distance on the opposite side of the line. So this is another one where we turn the object. So this one is a turn. So we have another turn, which is a rotation. And then if we look from here to a double prime, you see that this has just been moved straight down. So this is a shift, which is our translation. So when we look, the one that has a rotation followed by a translation is answer choice 2. So this is a rotation about Q and then translating parallel to line L. In problem C, we have our A and A prime. If we look at them, one is the mirror image of the other with this line in between. So this is a flip over that line, which is our reflection. And then when we look to a double prime, everything is oriented the same way. This is just a matter of shifting the object, which is our translation. So this is the reflection followed by the translation. And that means that D matches with 1. So if we look at this from A to A prime, we do have a translation. So our object has just been translated parallel to line L. And then from A prime to A double prime, if we look, this has been the mirror image or flipped across that line. So this is our reflection. So number 1 is diagram D. So we're going to do some glide reflections, and then we're going to sketch the image in the coordinate plane. So with problem 11, we're going to start with point A at 1, -3. According to our rule, we're then going to do a translation. And remember, a translation, you do exactly what it says. So we're going to add 2 to the x coordinate, do nothing to the y. So this means that my A prime is going to be at 3, -3. And then we're going to do a reflection in the x-axis. So when we look at problem 11, a reflection in the x-axis means we're going to take our point and we're going to change it by doing the x value the same, but the opposite of the y value. So for our A double prime, we leave the x value the same and do the opposite of the y value. So this one is going to be at the point 3, 3. Label it with the problem number because all of them are going to end up at A double prime. Problem 12. Once again, we're starting at the point 1, -3. Our first task is to do a translation. So our translation is to subtract 4 from the x and to add 3 to the y. So I subtract 4 from the x and add 3 to the y to get my A prime. And then we're going to do a reflection in the line y equals 2. So we go down here, and for problem 12, we're going to use this rule. So we're going to take our x, y coordinate and change it by keeping the x coordinate the same and doing 2 times the number 2 from our equation minus y. So we're going to leave the x coordinate the same. 2 times 2 is 4. 4 minus 0 is 4. So this particular problem is going to be at the point -3, 4. Problem 13, once again, we begin at the point A of 1, -3. We're going to do our translation. So this time we're going to subtract the 3 from our x coordinate and add 2 to the y. So 1 minus 3 is -2, and -3 plus 2 is -1. And then for our reflection, it's in the line x equals 2. So for problem 13, we're at the x equals. So we're going to take our ordered pair that we just got, and we're going to change it by doing 2 times the number 2 from our equation minus the x coordinate, but leave the y coordinate the same. So this is going to be 4 minus the x coordinate. So 4 minus -2 is at 6, and we leave the y coordinate of -1. So this one is going to end up at 6, -1. In problem 14, we start at the point 1, -3. Our translation tells us to add 5 to the x-coordinate, and it tells us to subtract 4 from the y-coordinate. So that means A prime is going to be at 6, -7. And then to get our final destination, we're going to reflect in the line y equals -5. So for problem 14, we're back down here to y equals a number. So our ordered pair is going to change by keeping the x-coordinate the same and doing 2 times the number -5. So we got that from our equation, minus y. So this is going to be -10 minus y. So we leave the x-coordinate the same, and -10 minus -7 is -3. So this one is at 6, -3. So do your translation, and then use your translation answer with your reflection. Last set of problems, we are asked to describe the composition. First thing we need to do before we can describe the composition is we need to locate our pre-image, which is the plane ABC triangle. Our first image, which is the A prime, B prime, C prime triangle. And then we need to locate our third image, which is the A double prime, B double prime, C double prime triangle. And then we just take them one at a time. So we're going to describe how to get to our first image, and then we're going to describe how to get to the second image. So in our first one, pay attention that A goes from being on the bottom to being on the top, and C stays in the same location. And if you look, we are flipping across the line. So this is a reflection. It's a mirror image of it. So our image is the mirror image. So this is a reflection. Remember, to describe a reflection, you have to tell me which line we're going across. So simply locate the line that is exactly halfway between the two shapes. So this is halfway between A and A prime, halfway between B and B prime, and C prime are both on this line. And this line is the horizontal line that is an axis. So you can either call it the x-axis, or you can call it y equals 0. Either one will work. To get from our first image to our second image, our shortest side, our middle side, and our longest side are all turned the exact same way. This is just a matter of shifting the triangle up and to the right. When you do a shift, it is a translation. When we describe a translation, we can do vectors in component form or coordinate notation. So if we do coordinate notation, we're going to figure out how to go from one to the other. So I have to go up 2 spaces, and I have to go right 6 spaces. The horizontal goes with the x, so right 6 is an addition of 6. The vertical goes with the y, so up 2 is a plus 2 with the y coordinate. In our last example, when you look at going from our A to A prime and C to C prime, so our A seems to slide across, but our C is not just across from it, but it's up. So this is actually a twist or turn. So this is a rotation. Now remember, a rotation is a 3-part description. I need to know the angle, the center, and the direction. The direction is the easiest part because we're going from the left to the right. So this is counterclockwise. Right to left is counterclockwise. To find the center, look and see what you can find that appears to be about halfway between A and A prime. A lot of times we are just using the origin, so we are turning this about the origin. And then the angle here is 90 degrees. Now, it appears that at first glance, we are just taking triangle 1 and shifting it down to get triangle 2, but that's a little bit deceptive because this happens to be an isosceles triangle. So notice that A prime and A double prime, one of them is on the bottom and one of them is on the top. So this is not just a slide it down because A has changed positions. So if you look, there is a line exactly halfway between A and A prime. And if you look, that same line is exactly halfway between B and B prime. So when you can find a line exactly halfway between all of your points, this is a reflection in that line. And this particular line, it's horizontal, so you can either say y equals the y coordinate it goes through, or because it's y equals 0, we could just call it the x axis.